Hey, howdy, space nerds. We've got a really special episode for you today. On Wednesday, March 14th, we taped a podcast episode in front of a live studio audience here at WMFE in Orlando, Florida. It was really great fun. We had an awesome panel and an awesome audience. So that conversation in its entirety is coming up. But first, more exciting news. That night, we released our first ever mission patch for fans of the podcast. That's right. This podcast has its own mission patch for you to collect, display, or put it on your flight jacket. It's also the first time you can show your support directly to this podcast. So for a donation of $32.10, follow me here, 3210, get it? 3210, get it? Huh? We'll ship you this beautiful patch. The patch was designed by Tim Gagnon. He's an artist who worked on many patches for NASA, including some shuttle missions. You can check it out and snag one of your own online. Visit WMFE.org/patch. That's WMFE.org/patch. And we'll have a conversation with Tim about what went into designing the patch, and we'll talk about some of his previous work and what you have to do to design patches of your own. All right, on to the show. Well, live from the studios at WMFE in Orlando, Florida, this is the Space Exploration Podcast that asks the question, are we there yet? Hi, I'm Brendan Byrne. Florida's Space Coast is roaring back to life. Nearly a decade after the shuttle was retired, we're on the brink of a new age of space exploration that leverages commercial and academic partnerships to send humans farther into the solar system than ever before. And NASA is working on its next big rocket, the Space Launch System at the Kennedy Space Center. To explore this bright future of space exploration from the Sunshine State, I'm joined by a panel of astronauts, scientists, and space visionaries here in the studios of WMFE in Orlando, Florida. I'd like to welcome Robert Cabana, the director of NASA's Kennedy Space Center. Bob was selected as an astronaut in 1985, and his first flight was on STS-41 Discovery, my favorite shuttle, launching in 1990. He'd go on to fly 3 more shuttle missions, logging 37 days in space, and he served as the director of Kennedy Space Center since 2008. Bob Cabana, thank you so much for joining us.
Thank you so much for having me, Brendan.
Dr. Addie Dove is a planetary scientist and assistant professor of physics at the University of Central Florida. Go Knights. Her research interests include dusty plasmas, collisions, and understanding how planets formed. Her experiments have flown to space on many different launch vehicles, and she's conducted experiments on parabolic flights, the Vomit Comet. Addie, Dr. Dove, thank you so much for joining us.
Thanks for having me.
And also Bob Richards, a space entrepreneur and futurist. He co-founded the International Space University and the group Students for the Exploration and Development of Space. In 2008, he founded the Singularity University, an institution based at NASA's Research Park in Silicon Valley, dedicated to preparing humanity for accelerating technological change. Now he's hoping to land the first commercial payload on the moon with his company Moon Express, where he serves as founder and CEO. Bob, thanks for joining us as well.
Happy to be here.
And later we'll hear from Nicole Stott, who served as a shuttle mission specialist and flight engineer on the International Space Station. So Bob, I want to start with you. So walk us through the transition at the Kennedy Space Center. The shuttle retired back in 2011. What was the vision for KSC of both state leaders and folks at NASA HQ for the role of the spaceport in what we now call the post-shuttle era?
And, you know, I'm not sure everybody had the vision back then. The shuttle Atlantis landed after its last mission, STS-135, on a Thursday in July of 2011. That Friday, the very next day, 2,000 people got pink slips and walked out the door. And yet that was probably the best shuttle mission we ever flew. Those folks were so dedicated right to the very end. We went from a workforce of 15,000 contractors and civil servants down to 7,500. And then, right before that, not long after that actually, the Constellation program was canceled, and morale was at the bottom. But how many times in your life, in your career, do you get to define what you want your future to be? And through an iterative process, you know, the first thing I said when I got down to KSC in 2008 was the shuttle program's going to end. We have to start planning for our future. And folks didn't want to hear that. And in the past, NASA KSC has been dependent upon one program, be it Apollo, the shuttle, you know, and now we have transitioned to this multi-user spaceport that is both government and commercial, crew and cargo, to and from low Earth orbit and beyond, and we're not dependent on any one program. A lot of folks think that, well, there's this war between NASA and government, commercial and non-commercial, and it's not. We need both if we're going to be successful. They're integrated. If we are going to be successful as a nation, we need both our government and our commercial program integrated. So we said, all right, we got all these excess facilities that we can't use. We only need for our exploration program one launch pad, one mobile launcher, one crawler transporter, one high bay in the VAB. All this other stuff, if we don't need it for the exploration program, what are we going to do with it? And part of our goal is to enable commercial space operations. So we went out with an announcement for proposals, and the very first agreement we signed was utilizing Space Florida to take over Orbiter Processing Facility 3 at the Kennedy Space Center. They have now leased that to Boeing, who is in competition in the Commercial Crew Program, where they are building the CST-100 Starliner in that facility. Which will take
astronauts to the International Space Station, right?
Absolutely. And we'll talk more about Commercial Crew. But, so now that is a fully utilized facility for commercial space, all right? Launch Pad 39A, where all the flights that went to the moon launched off Pad A, Apollo-Soyuz test project in Skylab launched off B, and then the shuttle utilized both pads. We're only utilizing Pad 39B for exploration. So Pad A was just going to sit there and rust away in the salt air. Instead, we signed a use agreement in 2014 with SpaceX to utilize that pad for 20 years, and they pay all the maintenance and operations on it and maintain it. Right? It's no cost to the government, okay? They had their first successful launch off that pad in February of 2017, and they went on to launch 12 flights off that pad since it's been reactivated, including most recently here the Falcon 9 Heavy, and hopefully by the end of this year they're going to be launching Commercial Crew off that pad with the Falcon 9 and the Crew Dragon. So that, and then Exploration Park, another partnership with the state of Florida, Space Florida, a research and development park outside the secure perimeter but still on government property. We now have OneWeb. We're building a satellite manufacturing facility for them. Space Florida is. Blue Origin is in Exploration Park, and they're going to expand. They're going to be building their new Glenn rocket there and launching Cape Side off Launch Complex 36 that they're transforming down there. So this is a really exciting time as we have a few, think about this. In all of human history, 3 nations have sent humans to space: Russia, the United States, and China, right? Today in the United States, we have 3 United States companies building human spacecraft to take humans into space. Lockheed Martin with the Orion capsule on SLS, Boeing with the Starliner, and SpaceX with the Crew Dragon. And that's pretty amazing.
Now, is that the vision you had when you took over Kennedy Space Center?
So our vision was, I had just come from, prior to coming here, I'd been the deputy director at the Johnson Space Center in Houston, and I was asked to go be the director of the Stennis Space Center in Mississippi. And Stennis is where they test the engines for the space shuttle, but it's also a federal city there. There is more than just the U.S. government operating at Stennis. And so I learned a lot there on what is the art of the possible. And coming here, I think we even expanded on that even more, bringing the commercial companies in that we have. But so the vision was to truly transform to this multi-user spaceport that we have. And it was a planning process. It was an iterative process over time to get to where we are.
Now, one of those private companies that's setting up shop on Florida's Space Coast is your company, Bob, with Moon Express. What was... why did you decide to come down here to Florida and... well, let's back it up. What is Moon Express? What do you want to do? Let's talk about it. I forget that people don't...
Thanks, Brendan. So perhaps not quite as well known as SpaceX, MoonX is also trying to make some history on the Space Coast. We are a commercial space company, privately financed. We're building a family of robotic explorers that will be able to reach the moon and explore the moon for science and commerce. We relocated here to the Space Coast from California just a couple of years ago. So we're renovating currently Launch Complexes 17 and 18 at Cape Canaveral. That will become our new home. And we're proudly an industry partner of the Kennedy Space Center. And Bob, you'll remember that we did our first test flights of our spacecraft at the shuttle landing facility. So again, this narrative of commercial and government optimizing resources and creating something bigger than both, and a great future for all of us.
Tell us a little more about some of those first missions, because I like the way you describe what the actual probe looks like, the MX-1. What does it look like?
It looks like R2-D2. It really does. There's just no doubt about it. It looks like R2-D2. But it's a robot that can fly through space from Earth orbit, reach the moon, land on the moon, hop around, do science. It's just a beginning. We look on the moon as Earth's 8th continent. We want to travel across the ocean of space. It's not that far relatively in the solar system. It's only 250,000 miles, still a long way. Like only 3 governments have sent humans into space. Only 3 governments have ever landed anything on the moon. So we're a small group, privately financed, from Silicon Valley, trying to do what only superpowers have yet done. But we hope to democratize access to the moon and collapse the cost of access to the moon, and do for space what CubeSats did for Earth orbit. Really open up, right, research for the moon for students and a whole new market for us as a business. But our vision is, in the long term, is pretty big. We also look at the moon as a opportunity for humanity to start expanding across the solar system as a multi-world species, and we're looking at the resources that we continue to discover on the moon as a potential to help leverage our future, perhaps help make life better here on Earth, but certainly support our future in space.
Dr. Addie Dove, another kind of relationship between NASA along with commercial partners is also with academia as well. You as a researcher, and you have students as well. Can you kind of explain the partnership that UCF has with the Kennedy Space Center?
Yeah, so UCF was actually founded as an institution to develop and train engineers to go along with the Apollo program and Kennedy Space Center. And it was originally Florida Technological University, I believe. And their mascot was the Citronauts, which is still one of the best mascots that's out there. But so FTU evolved into UCF, and there's been good partnerships off and on with Kennedy for a long time in terms of engineering and science that's been established. So I'm a planetary scientist. I'm interested in studying the moon and asteroids and other planetary surfaces. And one of the things we do is we work with groups out at Kennedy like SwampWorks, which is working on understanding how we interact on these planetary surfaces. And we also work with a lot of the commercial companies who provide flights. So we're sort of in between the government and the companies, in that, like, a lot of times I get funding from NASA that sometimes has allowed us to fly on NASA vehicles, but a lot of times now it's to fly on with companies like Zero G that provide parabolic flights, or with MoonX, hopefully, that can provide us rides to the moon. So there's this really nice synergy that researchers and planetary scientists and engineers can take advantage of to get us to the destinations we've wanted to go to for a long time, but haven't necessarily always had the ways to get our science and our engineering there.
Now, the Trump administration, along with the National Space Council, has turned this country's space exploration focus on a return to the moon, and we have private companies like Bob's Moon Express that are interested in going to the moon as well. Addie, as a planetary scientist, what can we learn from going back to the moon? What's left to learn?
So much.
Well, you've got an hour, so go for it.
Oh, man, okay. So there's this really good map I've seen that is the places we've explored on the lunar surface. So people are like, oh, we've been to the moon, whatever, we don't need to go back. But if you put a map of the locations we've actually been to on the moon on, like, a map of the Earth, it's definitely smaller than the continent of Africa, and I think it's even smaller than, I forget exactly what the size of it is. Anyway, it's a very small region on the lunar surface, and it was on sort of a homogeneous section of the moon, right? All of the areas we landed were pretty similar because they were safe, and we wanted to send astronauts there, and they were a little bit different, but they were all places we could see and sort of scout out ahead of time. But there's so much more. That's like going and sampling, like, in Texas and Florida and Kansas, right? So, and then you know everything that's in the United States. That's not really true, right? There's so much more science left to do on the moon, and as Bob mentioned, there's all these resources there that we've been discovering in the last 5 or 10 years, like water and other minerals and things like that we can utilize to actually make a more sustained presence on the moon.
And Bob, what's your interest in the moon?
First and foremost, to provide some awe and some wonder back in I'm a child of Apollo. I mean, I grew up in the excitement that there is an infinite opportunity in space, and I also became an orphan of Apollo when that program ended so abruptly and so unexpectedly. But in that time frame, I think we need this sense of awe, wonder, and excitement, especially for the young people. And so let's get back. Let's get back. Getting back to the moon is going to up the awesome of living. And it's great to wake up every day and really look forward to something exciting and not just worry about the day-to-day problems we have here on Earth. But there's even better news than excitement and awe. The moon is a great. The moon is like a sister world to Earth. It's the closest island if you consider our solar system like a planetary archipelago. It's the closest island that we can get to learn how to live off planet. It's not exactly like other planets, but there are a lot of things we need to learn how to live off planet. The good news also is that we can use robots for initial exploration, reconnaissance, gather data. You can take a little bit more risk with robots than they don't complain yet, but someday they might. But we can take more risk right now and not worry about it too much. But looking at the moon as the 8th continent of Earth and being able to tap into some of the resources, you mentioned water. So water is like the oil of the solar system. Its constituents, hydrogen and oxygen, H2O, is rocket fuel. It's also the stuff of life. We need it to live, but it's also rocket. It would mean that we don't have to take all the fuel with us in order to do things. We can refuel in space. Imagine if you needed to take a trip across the country and needed to take all your fuel with you in the trailer behind you. That would be a lot of fuel. But if we can have a gas station in the sky, it changes the economics of lunar resources, and it makes the moon a gateway to the solar system.
Bob Cabana, what's Kennedy Space Center's role in this new ambition to return to the moon?
Well, whether it's return to the moon or go on to Mars, our role is to prepare the launch pad and all the facilities necessary to process and launch the vehicles to go there. And we hope to have a role with both commercial and government vehicles. The Space Launch System with the Orion spacecraft, right now we're looking to launch on a test flight in December of 2019. It's our goal. By the middle of this year, we will have the construction of all the hardware and facilities necessary to process and launch that vehicle complete at the Kennedy Space Center. The launch pad, 39B, is just about complete now. We're finishing up the new flame deflector, but it's essentially done. It's got a refurbished propellant distribution system, water sound suppression system. It's all fiber optic now instead of copper. We pulled all the copper wire out of it and all the way back to the Launch Control Center. In fact, we made $620,000 in scrap off the copper that we reinvested back into the project. It's got a state-of-the-art lightning protection system. It's ready to go. The mobile launcher will be complete here this summer to support the Block 1 of the SLS. We've got a couple more arms we got to hang on it yet. We've got one that's left in testing, but that's a very complex structure.
What's the mobile launcher? Explain to us.
The mobile launcher supports the rocket when it's out at the pad. It provides all the services that the vehicle needs. We've gone to what's called a clean pad concept. If you look at the shuttle, it had a fixed and rotating service structure out there that protected the vehicle and provided all the propellants and quantities of fuel and whatever that it needed while it was out there, electricity, conditioned air, and so on. The mobile launcher provides all that for the SLS. It rolls out to the pad and it plugs in and gets all that, and then the mobile launcher, the tower itself, feeds the rocket. All right, and it holds it in place and everything till it's time to launch, but it provides it with all the fuel, electricity, conditioned air, and so on. So this allows us to, since if we only launch once a year, it's foolish to have a pad just sit out there vacant for 51 weeks. So it allows us to have other rockets be able to launch off that pad using a mobile launcher that's unique to their rocket but plugs into a common interface out at the pad. So the mobile launcher will be complete. The crawler transporter, we have 2 of them. They were built for Apollo. They were also utilized for shuttle. We've totally modified crawler transporter 2. It has larger wheel bearings on it to accommodate the higher weights. It's got new jacking elevation and leveling cylinders, new generators, totally redone. It's going to be the crawler transporter that eventually takes us to Mars one day. High Bay, let's say High Bay 3 in the vehicle assembly building has been totally transformed to support SLS and Orion. All the old platforms have been taken out of it. We have new platforms, 10 of them installed, and what's unique is they slide in and out like the drawers in your kitchen and come around the rocket. And they're adjustable, 8 to 10 feet up and down, and they have inserts in it so that as the rocket grows and the outer mold line changes, you don't have to redo everything. You just adjust the platforms or put a new insert in it to accommodate the new outer mold line of the rocket. The high bay is complete now, ready to receive the mobile launcher, and that'll be brought in by the crawler transporter for testing. So that's complete. The building, the facility that fuels the hypergolics, the propellants that are used for the reaction control system, all the hazardous commodities for the Orion spacecraft, multi-purpose payload facility, that is complete. We're going through the final verification and validation of it. So, as I said, we'll be complete with all the construction this year, ready to support the launch. I've told my team the Kennedy Space Center is not going to be the reason we don't launch on time. One of the things that we still have to work on, kind of the long pole in our tent, is the software for the Spaceport Command and Control System and the ground flight interface software. And I think we've turned the corner on that. We'll get it done so that we're ready. So that's our role. And then, just as we processed all the modules for the International Space Station, our goal is to be that processing facility where the final integration and test is done for the modules that are part of the lunar orbiting platform gateway that's going to be around the moon.
So this is like an international space station
it's like
around
a small space station orbiting the moon with a reusable lander. Instead of one time, we can go back and forth to the surface of the moon. We can send Orion and a crew to live there for 60 to 90 days. So we can adjust its orbit. Well, eventually we can go to Mars from there. We can fly Orion to there, have a habitability module that we dock with a propulsion module that allows us to leave from there to go to Mars. But just as on the space station, if there's a problem right now, the crew can be home in a matter of hours, all right? On the moon, we can be home in a matter of days, 2 or 3 days and you're back. Whereas when we go to Mars, it's going to be, with current propulsion technology, you're talking months, maybe 6 to 8 months or longer in order to get home. So what we learn going to the moon and how we operate and the systems that we need are going to be critical as we continue to explore beyond our home planet. And that's our goal. It's our destiny to explore. One of my heroes, John Young, he was chief of the astronaut office when I was selected to be an astronaut. Flew the first flight of Gemini with Gus Grissom, went to the moon, walked on the moon, flew that first shuttle mission, the gutsiest test flight ever flown, recently passed away. But John was very vehement about single planet species do not survive. We need to establish a presence in our solar system beyond planet Earth if we are going to survive as a species. And I think, we're laying the groundwork for all of that now, and I think it's critical to our future to learn, to grow, to expand our knowledge, and to be able to survive beyond planet Earth.
Now, you mentioned this in your response that the Kennedy Space Center isn't going to be the reason why there's a delay, but there is the SLS and Orion has seen some delays.
So we do have delays, and we're waiting on the service module for the Orion spacecraft that's being built by the European Space Agency. They've run into some delays. We've had some delays with the core vehicle that Boeing is building at the Michoud facility in Louisiana. But this is an awesome rocket. It's the core stage has a 27-foot diameter. It's the same diameter as the shuttle external tank. It utilizes solid rocket motors like the space shuttle, except instead of 4-segment solids, they're 5-segment solids. Those have been qualified. It utilizes 4 shuttle main engines. Now the RS-25 at the base. It's liquid hydrogen, liquid oxygen. the external tank on the space shuttle is the size of the hydrogen tank on this vehicle. So if you ever go to the Atlantis facility at the Space Center and you look at the 1-to-1 scale model of the external tank with the two solids, picture that sitting there, but that's just the hydrogen tank. The oxygen tank's above that. And then above that is the second stage, and above that is the service module and the command module on top of that. This is a huge rocket. And when we get ready to go to Mars, it's going to have 3 times the capability of a Falcon 9 to put cargo to Mars in metric tons, and twice as capable as the New Glenn rocket that Blue Origin is building. So, it's huge, and it's going to be our future for getting these modules to the lunar orbiting platform, the Gateway. When we launch that, we can do it in one flight and put it out there.
Now, I mean, I've been out there myself. I've seen all of, I've been into the vehicle assembly building with those new platforms. I was up way too high. It wasn't very fun. I've seen the mobile platform. The hardware is there. Is it frustrating to you to see that there seems to be these delays from whether they're congressional budgets or there's program slips? I mean, you've got the stuff there. You're ready to go. You want to launch.
Well, we're not quite ready to go.
I'm a little optimistic, sorry.
Sure, I'd love to see it sooner, okay? But we want to do it right, too. And there are issues, I'll tell you, to be honest, my goal for this year is I want to see commercial crew fly into the International Space Station. Right now, SpaceX and Boeing are both scheduled for uncrewed test flights in August. SpaceX is scheduled to fly crew to the International Space Station in December, and Boeing is scheduled to fly crew to the International Space Station on a test flight in November. Now, I don't know if they're going to make that, but that's currently what the schedule is right now. And I think it's critical that we have crews to the International Space Station on a U.S. rocket and not have to depend on our Russian partners. And that's going to be a huge milestone when we do that. So we're working really hard to make sure that we keep those two programs on track. And then that just leads into next year for SLS and Orion on their test flight. And I think our future is absolutely outstanding when you look at all that's going on and where we're going.
Now, you have a unique perspective because you're the only person in this room who's left the planet, basically. Can you kind of tell us what it's going to be like for those astronauts to launch from Kennedy Space Center? Maybe take us back to your first mission. What was that like?
Oh, gosh. So, all right. Long story or short?
Oh, wait. How much time do we have?
So my first flight, I really didn't know what to expect. I honestly had not seen a shuttle launch in person. I'd only seen them on TV before my flight.
Seriously?
Seriously.
I wouldn't get in that thing.
one of my jobs at the Johnson Space Center, I was the deputy chief of aircraft operations. And every time there was a shuttle launch, my boss, Joel Granny, who was a test pilot and a World War II naval aviator, he'd say, "Cabana, you're in charge." And he'd fly to the Cape with everybody to see the launch and left me in Houston to run things. But, that morning you wake up, and it's going to be very similar. In fact, we're updating crew quarters right now. But, you actually, you remember people sitting around the table in their crew shirts, and they got a cake there, and everybody's smiling and stuff. And then the cameras leave, and then you actually do eat breakfast. And I'd heard people get space sick. Space adaptation syndrome. And I don't get air sick, but I didn't want to get sick. And so I'm eating an English muffin and a cup of coffee because I'm addicted to caffeine. I'm trying to go light. And one of my crewmates, Bruce Melnick, it was his first flight too, Coast Guard astronaut. He's got steak and eggs and hash browns. He's putting hot sauce on his eggs. And Dick Richards, our commander, he looks over and he says, going for color and distance, I see. But Bruce didn't get sick.
I was going to ask. That was my follow-up.
Okay, and so then we go get suited up. We put on all that Patagonia long underwear and our orange launch and entry suits, and we go down the elevator, slowest elevator in the world, and walk out to the Astro van, and all these bright lights are on. It's 3 o'clock in the morning, and people are clapping and cheering, and we ride out to the launch pad, and we got a police escort going out to the pad, and Dick Richards says, "Hey, I bet this is the first time you've seen the lights in front of you instead of behind you." and then he turns to Dan Brandenstein, the chief of the astronaut office. He says, "Dan, aren't you going to lead us in the astronaut's prayer?" And Dan said, "Oh, yeah, I'm sorry, I forgot." And we all take a knee, and I got my head bowed, and I'm waiting for this solemn prayer. And Dan says, "Lord help you if you screw this up." And then he gets out and goes and flies the shuttle training aircraft, and we continue on out to the pad. And you get out to the pad, and normally the pad was just a flurry of activity. And now it's got these bright xenon lights shining on it. The rotating surface structure is rolled back, and there's nobody out there. It's just you and the crew that's strapping you in. And you take the elevator up to the 135-foot level, and it's venting, it's creaking, it's like it's alive. And you're looking at it, and you say, I can't believe I'm going to be inside that thing, 3 hours blasting off into space. And you can't turn around at that point. You pretty much got to get in and go.
Did you think about it? Were you like,
No, I was ready.
Okay.
I will tell you, though, people ask me, were you scared? And I was never scared, but with each mission, with each successive mission, I was a little more apprehensive when it came time to get in the vehicle. But once inside, I had just total peace. I know I was really good at what I did. I was well-trained. I had a great team on the ground supporting me, and God was going to take care of me and my family one way or another. But, it was awesome. So you're in there, and nothing prepares you for when it really lifts off. No simulator can match that. The shuttle launch experience is pretty good, but if I could sit on your chest while you were doing the shuttle launch experience, it would be a little more realistic. But it just, the main engine starts 6 seconds prior to launch. Depending on which vehicle you're on, you're not going to have that. With SpaceX and Boeing, Boeing on an Atlas V, SpaceX on a Falcon 9, the liquid engines are going to come up to speed, and you're going to lift off. Whereas the shuttle, the 3 main engines came up to speed, and that whole stack tilted forward because it's bolted on the solid rocket motors to the base, and then the spring tension comes back to vertical, called the twang. You can feel that in the cockpit up there. And then when you get back to vertical, it's bam, and those solid rocket motors, it just gets up and goes. It's just a sense of speed and acceleration. You're being pushed back in your seat, and all the pops and crackles you hear outside, you could hear them in the cockpit, and the gauges are shaking, and you're trying to read everything. And that's all I remember is that sense of speed and acceleration. 2 minutes and 5 seconds into it, the thrust tails off on the solids, and then they separate. And you're just on the 3 main engines, and it's like it's electric drive. It's just smooth, steady acceleration. About 7.5 minutes into the flight, you hit 3G acceleration limit, which was the structural limit on the wings of the vehicle. So the main engines start throttling back, but you're being pushed back in your seat. You can hardly breathe. And then 8.5 minutes into the flight, the engines shut off. And it feels like you stopped, but you just stopped accelerating. It's like you're in a freight train that got rear-ended. You come forward in your straps and your seat, and you've gone from 0 to 17,500 miles an hour in 8.5 minutes. And it's just, and you look out, and at that point you're about 65 miles above the Earth, and you continue to coast out to your apogee, but you see the curvature of the Earth out the window, and it's awesome. And I'll never forget Dick Richards. The first thing he said after main engine cutoff was, "Welcome to space, guys." And it's just a ride. I'd do it again in a heartbeat. Mm-hmm. And being in space is just awesome. But I don't want to, I could listen to you talk about that all day. That was what it was like to go into space. Mm-hmm. But, I'm very fortunate to have gotten to do what I've done. But I just love coming to work every day. I love being part of this amazing team that we have at the Kennedy Space Center, contractors and civil servants working together for the betterment of our nation. Mm-hmm. NASA's been #1 in the federal government 6 years in a row. And why is that? Well, I think it's because of our NASA family, but I think it's because we got a meaningful mission. People can go home at night and they can say, I didn't make a difference just for KSC or Florida or the United States. I made a difference for humanity, and I think that's special. That's really neat.
And you send stuff to space, which is really cool.
I know. Right? Anytime, I don't care. If you haven't seen a rocket launch, you got to come to Kennedy Space Center, because I don't care what's on it. Anytime a rocket leaves planet Earth, it's an experience. It's special.
So we talked about heading to the moon, learning how to live and work in deep space before we head to Mars. You spent about 37 days in space. We're going to hear from an astronaut who spent a little more time. She spent some time on the International Space Station. And the great thing about my job is I get to talk to astronauts all the time. So I just sent an email to Nicole, and I asked her, what are going to be some of the challenges of living and working in deep space? So let's go ahead and give a listen to what Nicole Stott had to say.
Hi, Brendan. Nicole Stott here. Thanks for the invitation to participate in your panel session about the future of space exploration. I'm really sorry that I couldn't be there with you and your group in person today, but wanted to take the chance to answer a couple of the questions that you passed on to me. I'm going to pull those up now and read them off and see if I might be able to provide some answer to you. The first question was, as someone who's been in space, what do I think is the biggest challenge we face when it comes to long-duration spaceflight? Well, I think, we're going to figure out how to build the rockets we need. We're going to figure out, if necessary, how to rotate that spaceship for some artificial gravity. We're going to figure that out, I think, pretty quickly relative to all of the other things we have going on. I think it's going to be, the challenge is really going to be the need to revolutionize, a lot of the human things that we think of as simple parts of our lives down here. The simple things that really aren't simple at all when you talk about space exploration. And that's things like, what are we going to eat? How to provide nutritional food that actually counteracts the effects of the space environment. Effective exercise equipment, hygiene facilities, equipment for communicating, with your family back on Earth. Things like dealing with the psychological effects of not seeing Earth out the window anymore. I think that's going to be a big thing, not having that visible connection to our home planet anymore. And what kinds of things are we going to be able to provide to our crews to deal with that kind of separation? Not to mention the radiation, the bone loss, and, the other physiological concerns that go along with traveling further and longer in space. I think, though, we're doing a really wonderful job on the International Space Station working through these kinds of things. I'm convinced that we will find solutions to these problems. I just think that it might need to be raised up a little bit in terms of where we're prioritizing our efforts in figuring out how to, travel for longer and farther in space. But, in the space program, we take very much a here's how we can approach to things. So I know that we will successfully achieve those solutions, and we will be going longer and farther in space. All right, the second question, let's see. That is, what advice would I give to young, aspiring people who want to get involved in space exploration? I think it's advice I give for a lot of things, and it's really for them to pay attention to what they're interested in, to what they enjoy. I think, these are the things that will open up interesting opportunities for them. It'll open up introductions to interesting people who will, share their experiences with them and support them in what they're trying to do. I think also, if you figure out how these things that you enjoy fit into what we need for space exploration and work on developing those and those things they love, into solutions to our challenges that we have here on Earth. Because everything we're doing in space is about improving life here on Earth. And it's always good to think about how what you're doing, improves life here on Earth, because that kind of thing can also be used to help improve the way we explore space.
So, Bob, I want to jump off of something that she said there, where everything that we do in space can come back here on Earth. Now, you've said the health of our home planet and the survival of our species will only be secured through the use of space resource and the expansion of Earth's economic sphere to the moon and beyond. Are you optimistic that we're on the right path?
I am optimistic that we're on the right path. The dinosaurs didn't have a space program. We do. What could happen to them? And, so we're in this is an amazing era that we're in. I thought it was cool during the Apollo era, and I can see some people in this audience that probably shared that with me. But for the young people that are here, this is the beginning of an irreversible movement of humanity from our home world to become a multi-world species. Future history will look back on these moments as when humanity became a multi-world species. This is it, and we're all playing this incredible role. You hear the enthusiasm in Bob's voice. It's just great to go to eat. The problems are huge. Sometimes there are bad days, but the work that we're involved in is just so important. And even though I've never had the privilege of working, let's say, inside of NASA, I've worked with NASA and the people of NASA for so long. It's an incredible community. It's inspirational, and what an amazing thing for my earliest memories being walking around the rocket garden at the visitor center. My earliest memories as a little boy, and now to have the honor and the privilege of working not just on the shoulders of giants, but shoulder to shoulder with the giants that have taught us about space and the reaches of the solar system. That adventure, that journey that we're on as humans will continue with NASA leading the way for sure. The frontier is unknown. But to know that we can all participate in this new world as students, as entrepreneurs, as commercial people, as scientists, and be a part of this expansion. The moon is just the first step, and people say the company is Moon Express, not the Moon Express. So any moon will do, Bob.
There's a lot of them out there, right?
Yeah. There's a lot of interesting ones.
Addie, you work front-facing with students that are coming in through UCF. You're teaching courses. You're helping graduate students. I mean, tell me about some of the are kids wanting to become planetary scientists? Are you seeing enough people coming into the programs?
Yeah, so I'm at UCF. I see a number of students across a variety of disciplines, right? So I teach students who are health sciences majors. I have a lot of engineering students that work in our labs. And then we have we have a growing and expanding planetary science program at UCF. And it's definitely captured the imagination of people around the country. There are students who go into geology or physics or astronomy or chemistry or biology, and all of these are different things that play into planetary science. So I had my background in physics and astronomy, but I work with people who are geologists, and I work with people who are chemists, and all of that feeds into planetary science as a discipline. At UCF, we have a huge number of students, obviously, just in general. But we have a huge number of students who come in to do engineering, and part of that is a lot of them want to go work for Boeing and SpaceX and Moon Express, hopefully, and Blue Origin, who are all now having these facilities here, so it's very exciting for them to see these opportunities open up in this area. And additionally, we build experiments. So I build experiments, as you mentioned, that fly on different vehicles. And so the fact that SpaceX and Blue Origin and NASA are all here right now gives us these amazing opportunities to build things, put them into space, show them off at conferences or in high schools, and really get people even more excited about it again.
Bob, you have, at Kennedy Space Center, you have a launch services department, and they're launch brokers, right? They find rides on rockets. Can you kind of explain how that works?
So they provide the vehicle for NASA's science missions. So they have a competition. They look at what class vehicle they need, what reliability, depending on the class of the payload and the expense of it. And then they go out and procure that vehicle and help make sure that it adapts properly to the spacecraft that are launching, and monitor it throughout the launch. And then once it's safely on orbit, then their job's over. But they got a very busy time coming up here. We just launched GOES, another weather satellite, but we got 6 launches in 6 months, starting with GOES. The next one coming up is TESS, which is going to look for exoplanets. That's going to be on a Falcon 9 rocket launching April 16th. Actually, our next launch is going to be not through launch services, but it's a cargo mission at the International Space Station on April 2nd. That's a SpaceX Falcon 9 also. So, and the other neat thing that they have is there's extra space on these vehicles. And so they offer it up for these CubeSats, like Addie's been working on. So we have a lot of student experiments that end up going up, and the Launch Services Program helps make that happen. But Amanda Mickiewicz and her team, they're just doing an outstanding job supporting NASA's science missions.
And Addie, can you kind of explain what a CubeSat is for folks that don't know?
Yeah, so a CubeSat is, and it's been mentioned a few times up here. So a CubeSat is basically a tiny spacecraft, and I should have brought my mock-up with me. But a CubeSat is any number of units, where one unit is 10 by 10 by 10 centimeters, or 4 by 4 by 4 inches, so about that big.
It's like a tissue box.
A 2U CubeSat is like a tissue box, yep, and then you can have 3U, you can have 6U. Some people are doing like 27U CubeSats, but that's a little big for a CubeSat. But so you bring out a spacecraft that's this big, and you're like, no, this is real size. This is actually a spacecraft, right? It's something that's going to go up into space. But you mentioned earlier, Bob, that it's democratizing access to space. So the idea of these CubeSats is that they're little tiny payloads that you can just put off-the-shelf components. So you can put your Raspberry Pi in there. You can put your Arduino in there.
Not an actual Pi. That's a computer.
It is Pi Day.
It is Pi Day, yes.
But yeah, a Raspberry Pi is a little mini computer.
Addie's sneaking food on your rockets there, Bob.
Yeah, we need to develop food on our rockets. So, And you can do a lot of off-the-shelf components, so high schools are developing these. A lot of colleges, we're developing a couple right now. We have funding through the Launch Services Program, for instance. And they go up as secondary payloads primarily on a lot of these bigger rockets. So you get sort of a free ride because you're hitching along with another bigger payload. There are a bunch of companies now, though, that are working on just launching CubeSats, so little small launchers to launch CubeSats into orbit. And the other exciting thing about CubeSats is there's a lot of potential to send them on these deeper space exploration missions. So like when the Exploration Mission 1 launches with SLS, it's going to go out toward the moon. It's going to have CubeSats aboard. And there's going to be some that go to Mars, and hopefully with Moon Express also. So there's a huge opportunity for these little tiny payloads to do some really cool science and some cool technology demonstration at a relatively low cost.
Bob Richards, you've got folks like Dr. Dove working at UCF. There's tons of other universities with a space focus in the area. There's Embry-Riddle. There's Florida Tech. I'm sure I missed a few. I'm sorry. Did that kind of lead you to come here? Was it that brain pool that you could get of space people that could come work for you?
That was a big
here?
part of it, for sure. It was kind of an offer I couldn't refuse. The personal motivation was there for sure because my earliest memories, my connection to the Space Coast, and being a Canadian that escaped the winters in January with my family every winter and came down here to thaw out for a little bit. So it was always embedded in but when in 2014 when I came out with part of the company to do our first test flights at the Kennedy Space Center, NASA was flying Morpheus, if you remember, at the shuttle landing facility, and we were flying our little vehicle we called the MTV. I think you had the cooler name, actually. And so you had this government spacecraft and this private spacecraft competing for times to act. What a great problem to have that. So we learned, I learned in particular, that it wasn't just a great place historically. It was just an amazing place to do, to everything I needed was here, including the talent, the people, the facilities. And we met some friends from an organization named Space Florida, which represents the state of Florida and trying to provide economic incentives to attract companies. And the state of Florida offered us a great deal if we would relocate the company here with the 45th Space Wing. Offered us eventually. We were originally at Launch Complex 36, where Blue Origin is now. And we worked that out, and now Blue Origin is there, which is great for them. And we kind of were offered Launch Complex 17 and 18, which we're now investing in. But we're co-investing with the state of Florida into these facilities. And so we're custodians of hallowed ground. We're here making it better, investing private capital. We'll do some amazing things. But with the talent, the universities, the economic development, the talent at the Kennedy Space Center, just the Space Coast itself, there's no other place. This is the place you need to be to go to the moon. And it's just a great privilege every morning driving in to work and seeing those towers and all the facilities. It's just an amazing place.
Now, if you're successful, we all hope you are.
Did you say if?
Sure.
When? When?
You will be the first private company to land a payload on the moon.
I say we will be the first private company to reach the moon.
Okay.
Define land. We will touch the moon, and I really hope we touch it as softly as we intend the very first time. But it's really hard. You're traveling at this, faster than the bullet, and you use those lunar parachutes aren't just going to work. You've got to slow down from faster than the bullet to basically zero as you touch the surface, and it's not like we haven't done it before, and the physics hasn't changed. It can be done. It was done in the 60s. But getting to your point of the CubeSats, what technology has done is it's dematerialized hardware into software. It's allowed spacecraft to come smaller and smaller. We're able to simulate landing on the moon millions and millions of times. Nothing beats hardware, because hardware, you actually have to build hardware and test it, but the ability to simulate missions millions and millions of times allows a small company with relatively small amounts of capital compared to what the government programs needed back in the 60s and 70s to do something with 50 or 100 people that used to take thousands to do with a spacecraft that costs millions, not hundreds of millions. And this is what's going to change the world. Yeah.
Now, I know how difficult it is because I play Kerbal Space Program, and I'm very good at it. So
you'd be surprised at how many of my engineers I say, please play
sure.
Kerbal. Yeah, then come back and ask me that question.
Now, we've had the chance to talk, I think it's been over the past two or 3 years, and you've told me about all these challenges of building this thing and landing on the moon and all that, but it seems to me that the toughest challenge has been regulation right? Government regulation. Explain to us how you've navigated this and got permission to shoot something to the moon.
So who knew before blazing a trail to the moon, we needed to learn how to blaze a trail through Washington, D.C. So the only spacecraft that have ever gone into deep space, left Earth orbit, and gone into deep space have been government spacecraft. There's been no private spacecraft that have ever gone into deep space, to the moon or anywhere else. Yes, now there's a car out there, but this was back in 2015.
Did he thank you for that?
Well, there's an interesting nuance there between why didn't SpaceX. Well, let's talk about what we needed first.
Yes. We can turn the mics off too for the next part.
That would be fine. So in 2015, we were 1 or 2 years away. We're about a year away now from our maiden mission, and in 2015 we went to the there's something called the Outer Space Treaty, and that's a real thing, and that was signed in the 60s by mostly the Soviet Union and the United States worked out how nations were going to behave in space, how we weren't going to go to war in space. And since over 100 nations have signed that document, and to this day, it's the document that dominates how humans behave in space, what you can and can't do. You can't put weapons of mass destruction in space. You can't appropriate any celestial bodies. You don't. So it's a wonderful document, which is you can drive a train through the holes in the document, and that it doesn't say
or Tesla.
Right. So it's a very permissive document, or Tesla. It's a very permissive document, but since we were talking about the first private sector mission that would need to go beyond Earth orbit into the moon. There is a section of that document that says that any nation that allows any entity to leave its domain needs to authorize and supervise that mission. So there was no Department of the Moon to go and ask. There was no form to fill out. So we went to the State Department, the U.S. State Department, which is the body in the United States, the regulatory body that deals with international treaties, and we said, hey, we'd like to send a private robot to the moon. Is that okay? Are you guys okay with that? Do we have to? Is there a form we fill out? Do we just? And I didn't expect the answer. Regulatory risk, as part of the business risk of building the company, it was always there, but it was never a major risk in my mind until that meeting, when they looked at me and they said, "We really love what you're doing, and we're fully behind you, but there's no way we can say yes to that." Did you just say no? So there was no way so when any commercial rocket launches, it needs a launch license. It goes through a department of the FAA, a wonderful department that deals with all the commercial launch licenses. But the authority of that agency ends when the payload is released, and then other agencies take over FCC. But there's no agency that looks at authorization and supervision of missions that go beyond Earth orbit to the moon. So there's no way to say yes to that. So we began a multi-month process working with the White House, NASA, FAA, State Department, anybody with 3 or 4 letters that had anything to do with a spacecraft going into space. We had to invent out of thin air something we called mission approval. It just didn't exist. We invented a framework and reached basically a consensus, because there's no law and no regulation that's on the books even today. And on July 20th of 2016, we received the first ever, not just U.S., but government authorization anywhere in the world for a private space mission to the moon. And why is that different than a car? Well, one of the articles in the Outer Space Treaty talks about planetary protection. And even though the moon is much different than Mars, and we don't have to worry about it quite so much, planetary protection is not just about protecting the other planets from contamination and planting life before you discover it type of thing. It's also about reverse contamination of the Earth. So we had to address these things in our application, because we're going to touch another celestial body, which the Tesla hopefully will not.
Mm-hmm. I think they hope that
you don't need to worry about that when you're in deep space, but we did need to worry about that. So.
You make talking about regulation extremely interesting. Thank you for that, Bob Richards. I appreciate that. Bob Cabana, with the meteoric rise of commercial space companies like SpaceX, Blue Origin, Moon Express, there seems to be this perception that there's a new space race brewing, one that puts NASA against commercial players, but as we've discussed, that's not really the case. Where do you see the future of NASA leveraging this kind of momentum of private space industry that's popping up?
I think it's, for one thing, we want to commercialize low Earth orbit. Okay? We know how to get back and forth to low Earth orbit. We've been doing it for over 50 years. We want to do that really hard job of exploring beyond our home planet. So just as we have enabled commercial cargo to the International Space Station, we're working on enabling commercial crew. We'd like to have a commercial space station and just be able to buy science on it and send our astronauts up to it. So that's the goal for low Earth orbit. As we build this gateway, there's going to be a role for commercial companies in that also. There's going to have to be resupply. There's going to be all kinds of supplies, things that we are going to need as we operate in and around the moon, and they can get access to the moon. We'll do it with our international partners. It was interesting listening to you talk, Bob, about treaties and stuff. I had the privilege of helping negotiate the crew code of conduct for the International Space Station, which, we've got Russia, the European Space Agency and all its partners, Japan, Canada, and the United States, all working up there together. Well, that's an international document that had to be approved by their state departments, and it's not easy doing something like that. But if you look at the model that we have on the space station and how well we work together, I mean, they work as one crew up there. We don't work as people from different nations. And in spite of all our differences here on Earth and all that's going on politically, the crew on the International Space Station is doing just fine. They're working around really well. And
let me follow. Go ahead. I'm sorry.
Go ahead.
I was going to follow up on that and say, these are really ambitious goals. So putting together another space station around the moon, putting human boots on the surface of Mars. Who's going to lead that? I mean, this is going to be a multinational thing.
Absolutely.
Who takes charge and who's going to lead this?
So, I mean, if you talk to our international partners, they look to us for leadership. And I believe we will lead it. But I believe it's going to be an international cooperative effort when we go back to the moon and when we go on to Mars. Everybody's going to have a role to play. It's extremely expensive, for one thing. And I think it's right as we leave planet Earth that we leave it as people of planet Earth, not any one nation. So getting back to the competition, but again, it's a partnership. We're going to work together. Everybody's going to have a role to play if we're going to be successful. And it's not one or the other. If SpaceX and Boeing aren't successful, we're not successful. Right. Okay?
Now, you say that international partners look to you for leadership, but right now the agency doesn't have a permanent head of NASA. Does that kind of
we have very clear direction on where we're going and what we're doing, and I think we have great support for the plan that we have in place. We've got an awesome leadership team at NASA. Robert Lightfoot has just done an outstanding job for over a year now as our acting administrator, and I know Robert has announced his retirement, and hopefully we'll get an administrator named, but we have other people that can step up. We have a very clear path forward on what it is that we have been charged to go do, and we'll continue down that path.
I want to talk a little bit about competition as well. We talked about competition between
private. Competition is really good.
It's great, right?
It is, because it brings down prices, it brings innovation. People look for better ways of doing things. You don't just keep doing it the same old way. I think, competition is great.
What about competition of different spaceports? So we're looking at spaceports in Georgia looking to come online, Boca
Chica. Let me just say that the Kennedy Space Center is the world's premier spaceport. All right? And why would you go anywhere else? We have the facilities, we have the companies, we have the talent, we have everything right here on the Space Coast. I mean, Bob said it earlier. When you look at the universities that support us, when you look at all the companies that have moved here, the talent that is here, the engineering talent, plus the facilities and great launch pads. And part of going to orbit, obviously it depends on what you're going to do, but you may not realize it, but you're doing about 910 miles an hour right now. Down at the equator, you're doing 1,000. And that velocity helps get you to that orbital velocity of 17,500. So the closer you are to the equator, the less prop you need to get to orbit, depending on what inclination orbit you're going to. But, so there are advantages being where we are also.
So you're not worried about losing business up to
I've
Camden
got
or
all
South
the business.
Texas?
You look at what's going on at the Kennedy Space Center between SLS and Orion, Blue Origin, SpaceX. Another facility that we have is the Orbiter Processing Facilities 1 and 2 that support the Air Force's X-37 spaceplane that now lands at the shuttle landing facility, gets processed and launched right here at the Cape.
It lands unannounced, by the way. Thanks for that scare not too long ago.
Moon X. People want to be here. They want to be part of this amazing team. And so, no, I'm not worried about our future at all. We got plenty on our plate.
Addie, we've talked about human exploration, but also, right here from Florida Space Coast, some of the coolest robotic missions have launched. OSIRIS-REx, we've seen Juno, the Mars rovers. And I just want to end my questions with this one. It's a question that I get from a lot of people that aren't in this room here, but maybe you guys can take this answer and bring it back to people that ask you this question. Why does it matter? Why is it so important that we understand our solar system?
Oh, but you're just doing the light questions here.
Yeah, I saved the hard ones for the end.
So I am a scientist, but I was not a child of Apollo, but I am an explorer at heart, I think. And I think the other people up on stage have touched on this as well, is like, as humans, as species, right, we have questions we want answered. And a lot of those questions we still haven't answered here on Earth. But there's so many questions about how we got to be here and where we came from. And part of those are questions I ask in my scientific field, which is like, how did you form a planet, right? But it's also like, where did life come from? And those questions, answers to those questions, are elsewhere in the solar system. There's some of them here on Earth, but there's a lot of them elsewhere in the solar system. And there's also this just sort of drive to explore that I think we as humans have, and this awe that we've spoken of things in space and of going to space. And if we can get to the moon, and if we can get to asteroids and to Mars, right, that's a phenomenon that no one else on Earth no other species on Earth has ever achieved, right? Dinosaurs, sorry. They probably had some cool things, but not rockets, as far as we know. They didn't have rockets. So, I think that, like, moving beyond our planet will allow us to do science. It will allow us to learn more about ourselves as humans, and it will just open up amazing new questions and opportunities.
And I get to keep my job, so keep doing it.
And you get to keep your job. Are you gonna go?
No, absolutely not.
No. Part of the reason I became a scientist was so that if we go to the moon, when we go to the moon, I can go there and do my experiments there on the lunar surface. So,
although you did hard sell there, Bob Cabana. It did sound like a lot of fun. So I might be rethinking a potential journalist in space.
Brandon, you would really enjoy it. Trust me.
Wonderful. Well, we're going to take some questions from the audience. We have a microphone up in the middle there. If you just want to come up and line up, I'm going to first start with a question somebody tweeted me, and this is from one of Danielle Miller's students. She's an astronomy teacher. University High, right? She has a really cool class. So this is from her third period. And Bob Cabana, you might want to tackle this one. So many people who work in the space industry talk in a way that makes long-term goals and missions seem really close, even though they may be months or years away and millions of miles away. How do you keep yourself motivated when the goal is so far?
Oh, wow. So I guess my motivation is knowing what it is that we have to do as a nation and our drive to be successful. So it doesn't matter that it may take a while to do it. Everybody talks about, well, like SpaceX did it so much quicker. Really, if you look back on the time it took them to develop their rocket, it wasn't that much quicker. It wasn't any quicker than any rocket that's been developed. Some take a little longer, but the bottom line is, there is reward in knowing that you are participating in something that is going to make a difference. And I think having that goal, the strive, the drive to make that happen is what keeps you going. And then it's part of being this amazing team. Bob said it. Gosh, I just love driving to work in the morning, coming over the Indian River Bridge and seeing the Cape out in front of me with the sun coming up over the Atlantic Ocean. That's pretty awesome. We work in a pretty amazing place, and knowing what is going to come, what our future is, knowing that you can be a part of that. How can you? And I want to say to any student that's listening, it's not just technical people. We need everybody at the Kennedy Space Center. I don't care what your job is. you're launching rockets. You have a role to play. We need communicators, Brendan, to tell our story.
We even need lawyers.
We need lawyers. We do need lawyers, especially with all these international agreements and working with the FAA.
You need the lawyers, right?
Yeah, space lawyers.
But, and budget people and you name it. We need everybody if we're going to be successful, and anybody can come and be part of our team.
Wonderful. Your name and your question.
Hi, my name's Christy. That's an awesome segue, Bob Cabana, because I'm a mental health counselor, and I would love to work at Kennedy Space Center. But anyway, I was actually going to ask a question about mental health related to long-term space travel or living on Mars, if that's a long-term goal, living on the moon as a long-term goal. So I was wondering, you're the only person, again, in this room has left this planet, but I liked that Nicole touched on it earlier, that, the implications on mental health, even though there's massive amounts of screenings for astronauts, the long-term implications that someone leaves their family for an extended period of time. I think there was, discussion of people who are going to be colonists of Mars and never come back. So sending people who are therapists or doing long-term, distance therapy, that sort of thing. So I was wondering if anyone has looked into that sort of stuff at all. I know the High Seas program is a really awesome program. I very much support them and that continued research. So if anyone has any comments on that,
sure,
that would be awesome.
Absolutely. First off, we do have counselors at the Kennedy Space Center. It's our employee assistance program, and they do a great job helping our employees. But I would suggest that you contact the folks at the Johnson Space Center. That's where human health is situated for NASA and for astronauts. And long-duration spaceflight is different than short-duration spaceflight. And there are issues that we're looking at on what's going to be required for the health of astronauts being away from our home planet for an extended period of time. Being away from your family, I was a pilot in the Marine Corps. I spent a year in Japan without my family. We send guys out on aircraft carriers and overseas for 7-8 months at a time. So, family separation, we know how to deal with that. And we have such much better ways to communicate today. I think having that connection to be able to use the resources that we have for the connection is going to be important. But there is a different screening that goes on for astronauts that are doing short-duration flights as opposed to those that do the long-duration flights on space station. I was sharing a story earlier with somebody. I applied for the astronaut program in 1984 and didn't get selected, and I was really disappointed. And I went through the whole process and reapplied again and was fortunate to get selected the next year. And when I finished, we had interviews by 2 psychologists and took a bunch of tests. And when I finished up with one of them, Dr. Terry McGuire, when I got done the second year, he said, "You did better this year." And I said, "Oh, really? What did I do wrong last time?" And he said, No, you didn't do anything wrong. Nothing I said kept you from being selected. But, so it is part of the process, and there is an important role for that. And I think we have more to learn, but I think we need to take a serious look at, what kind of individual do we send off, and how many people, crew interaction, picking the right people to send together to be stuck inside a small spacecraft for a long period of time. That all goes into the screening that we do when we select astronauts. And since you got me, I got to throw one more thing out here. Nicole talked about what do you got to do to get to be an astronaut, and she talked about following your passion, all that stuff. That's really important. That's what I used to tell people too. That and being persistent. And then I said, but just because you're passionate about it, you got to have a little bit of talent in your passion also, okay? But I can't imagine today, this last class, we had over 18,000 applicants.
That's crazy.
And, it's unbelievable how many people are interested and qualified that want to be astronauts. So I'm really looking forward to these commercial flights and getting the cost down and having more people fly in space. But long duration is going to be a challenge.
That's a good segue. I'm sorry, go ahead.
Yeah, I was going to say, I'm glad you mentioned High Seas, and there are a number of other programs like that, too. So High Seas is this mission that's out in Hawaii, and it's basically they have this remote location that's a dome, a habitat where 6-ish people live at a time, and they've done 6-month missions, I think. So they do these extended studies, and in those missions there are a lot of people who are psychologists and biologists and a large range of scientists who go on these missions. There's also like the NEMO program here in Florida that does more of like how you do missions, but they're spending long-term in habitats. There's been other countries who have done some long-term mental health studies as well, but it's one of these things that like there are people of all different types of specialists, right, who are involved in NASA and in these long-term missions.
Yeah, we interviewed somebody from the High Seas program in a recent episode, which was absolutely fascinating and terrifying at the same time. So let's take another question from the audience.
Yeah, so hello, my name's Ian. I'm a local student grad a few years ago, right? So I grew up in Brevard, watched rockets and shuttles launch all my life. You mentioned, a large number of people applied to be an astronaut. Another astronaut question. So not everyone gets to be an astronaut. Do you see a day where there's another type of person that goes to space?
Oh, absolutely. I mean, as we move forward, what you call an astronaut, somebody who flies in space, I mean, I think it's going to be much easier Addie said already, she wants to go to the moon as a scientist and study. I believe that's going to happen. I think that when we have these commercial space stations, there will be scientists that go up and do research on these commercial space stations and come back down without all the extensive training that you'd need for an exploration mission piloting the first spacecraft to Mars or something. So there will be a role for people as we move forward. I believe we are going to become a true spacefaring nation planet.
Bob Richards, do you think that you'll be hiring, lunar riggers or, people that are going to be doing labor in the future to go to the moon and set up these bases and stuff like that?
So, there's a false dichotomy question, robots or humans. The answer is both. And we need to know how it feels, right, to go explore. But there's going to be practical things we have to do. So absolutely humans have to go. Maybe not the first missions. Maybe the robots can do some good work before we get there and maybe not complain for a while if something goes wrong. But absolutely, we need to see humans. And, in the future, the Homo Spacians that we become, because we will then branch off into different parts of humanity as distance and time and changes us. But whatever we do become on our descendants, it has to be about these biological creatures that came from a planet named Earth. Yes.
And in the near term, there's also companies like Blue Origin who right now are just doing research payloads, but who are now doing research payloads that are suborbital flights. And they are hoping to have human-tended payloads in the very near future. So they have their own astronauts or their own space flyers, right, who have been selected right now. SpaceX is going to have people that they select for a lot of these near-term missions as well. So there will definitely be other companies and other organizations.
Yeah. Great. Next question.
Okay. Thank you. I'm David Jordan. I volunteer for two organizations that I think, Bob, you're probably familiar with very well. One is AMSAT and one is ARIS. And these are two groups. AMSAT actually designs as amateur radio operators that design satellites. And also ARIS is amateur radio on the ISS. And I just wanted to, first of all, thank NASA for giving us the privilege of being able to schedule contacts between kids on Earth in their classrooms, and also with the astronauts on board the ISS. Also, AMSAT has been able to get a lot out of very discounted launches and free launches because of the LANA program. And these are very important to us. I just wanted to mention that and thank NASA for that, and also wanted to get any comments you all may have on that, on the education that's being provided by the ISS and the space program.
Anybody want to tackle that one?
Well, I can tackle that one.
Yeah, me too. Addie, you go first.
Okay. So I mentioned earlier CubeSats, and so the Alana program is what helps launch CubeSats into Earth orbit right now, but also puts them on the International Space Station. So some CubeSats are actually launched from the International Space Station. And there's also some payloads and racks on the space station called Express Racks, but they're operated by a company called NanoRacks that has really made it more available and more straightforward to integrate your payload into somewhere like the space station or some of these future suborbital flights. And so NASA is one of the primary funders of these types of things, right? Most of us get, there's actually a lot of NSF funding for CubeSats as well, the National Science Foundation. But so NASA provides a lot of these launch opportunities and also funding to build your spacecraft and to build hardware, and there's a lot of technology development that comes through that, and that can be done at universities, but also it can be, a lot of high schools have been selected for these and a lot of amateur organizations as well. And so it's a really interesting sort of new players in the field.
Does the UCF at this point have a lot of CubeSats that they're presently working on, and what are some?
We have at least 2 that I'm involved in. And then I think that there are a couple of other groups that have been sort of developing some technologies for it, but I don't believe they've been awarded a launch yet. And we're actually working with a university down in Puerto Rico on some CubeSats also.
So, by the way, I'm KC5HBV, but space is still cool. Hey, I mean, I talk to kids from K through graduate level in college, and they are excited about space. And anything that motivates that interest in students to look at something different. Ham radio operators, to be able to learn how to get your ham license requires some work and some knowledge to get that. And any student that is interested in that and goes through that and develops this interest in electronics and radios and so on, that's really important. And the programs that we have on the space station, one of my favorites, Don Pettit was up there quite a while back now, and Don used to do Saturday Science. And he'd make up these experiments and record them and send them down on his own time, his free time, and share them with the students on the ground. And they're great. You can go Google Saturday Science with Don Pettit and watch through his different classes. But, it's a unique environment, and it captures the imagination. And folks want to learn more. When they see it, they want to learn more, and so I'm all for anything that we're doing that does that.
We'll take one more question. I think we have time for one more.
Hi, my name's Claire. So I have an astronaut question. So I was wondering what you ate and what you wish you could have had available.
So Nobody asks us what we had for dinner tonight, do they?
What did you eat in space?
I had those crab cakes. So. First off, what we eat is really important, and the food is either freeze-dried or it's thermally stabilized, because there's no freezer that you can use for food, no refrigerator. So you have to rehydrate it. The thermally stabilized stuff, it might be in a irradiated chicken breast or something. It's all the food that you eat here on Earth. A lot of it is meals ready to eat, like the military uses, like spaghetti and meat sauce and all kinds of different things. For breakfast, I might have instant coffee with a Sara Lee Danish and some instant oatmeal. For lunch, take a tortilla and slap a chicken breast on it and heat it up. And for dinner, green beans almondine with potatoes au gratin and some dish. But one of the things that's really important that we're looking at is, and Addie talked about it earlier, but food in space. And KSC has got this experiment, it's called Veggie, but we're growing food for astronauts in space on a space station. Now they're talking about, I can't think of the name for it now, but it's essentially, a wall of food that would be on the gateway that they would grow in space, because, bottom line is fresh food is more nutritional than any processed or prepared food.
It tastes better, right?
It tastes better, but it also, there's a psychological aspect about seeing, when we talk about the psychological aspect of a long-duration spaceflight, to see something grow and to watch it. Bob's from Canada. I remember in the middle of the winter in Minnesota. And by the way, northern Minnesota is further north than a lot of parts of Canada.
It is, yeah.
But, to have a plant growing in your house when it's the dead of winter, there's a positive aspect about that. So not only do you see it and it's psychological, but you get the benefit of the nutrition too. So that's going to be a huge future.
Now, I'm going to get the last question, and I want to go to you, Bob Richards. It's not too often you get to talk to a futurist. And the name of the show is called Are We There Yet? And it's about our human exploration of the solar system today. Are we there yet? Are we ready to explore?
I think we're ready as a species. You know, we've been answering kind of seriously here because we are obviously still in our adolescence. We're making a lot of mistakes. Are we ready to go to space? We need to go to space. It's not a question of if, it's a question of when. We don't know that an asteroid's going to hit next Tuesday. Probably not, and wipe out the entire species. Probably not, but we can't say for certain. So we do need to go to space. Are we ready yet? I hope we are. I think Bob Cabana had mentioned the International Space Station. I think it's a wonderful. It is a microcosm of humanity at its best. We've learned how to work together, to cooperate. And if we can take those lessons out to the moon, we have a chance to try to, for the first time, conquer a new frontier without conquering each other. And I think that will be a great moment in history as we evolve from our adolescence into our adulthood.
Wonderful. Well, Bob Richards is the founder and CEO of Moon Express. Bob, thank you for speaking with us. We also have Dr. Addie Dove at the University of Central Florida, planetary scientist. Thank you, Addie. And Kennedy Space Center Director Robert Cabana, thank you so much for your time as well. A huge thanks to all the fans that came out. It was so great to see our studio packed with people passionate about space exploration. Big shout-outs to Jenny Babcock and the WMFE membership team, and to my station's general manager, LaFontaine Oliver, for making the night such a success. Support for Are We There Yet comes from the listeners of WMFE. This episode was engineered by Mac Dula. Our theme music was composed by Kevin McLeod. You can join the conversation online. We've got a Facebook page. Search for Are We There Yet Podcast. Or you can take to Twitter. The show is AWTY Mars. Get it? Are We There Yet Mars? And I'm at Space Brendan. You can find more space news online at WMFE.org/space. And until next time, I'm Brendan Byrne. Thanks for listening.